Hi, this is Professor Clemens. Welcome to Chapter 3. Let's talk about descriptive statistics and normal distribution. Your objectives: illustrate types of data and associated measurement scales, discuss summatation, notation, and reporting data, understand measures of central tendency and variability, and describe standard scores and their purpose of measurement. Describing data. Descriptive statistics. Mathematical summaries of performance. Example, the best score. A performance characteristic. Example, central tendency, variability. Characteristics of the distribution. Example would be symmetry. Here's your scales of measurement: nominal, ordinal, interval, and ratio. The nominal is categorical in nature. It's no notion of order, magnitude, or size. So examples are male, female, hair color, brown, black, blonde. Ordinal is categorical in nature. Numbers are ranked in order, but the differences between ranked positions are not comparable. So examples: finishing place in a race. Example, how do you feel today? Very unhappy, unhappy, okay, happy, very happy. Scale or continuous. Numbers are continuous in nature if they can be added, subtracted, multiplied, or divided, and the results are meaningful. Have a distinct place on a number line and can be interval or ratio in form. Interval, equal or common unit of measurement. Example, your temperature, Celsius or Fahrenheit, or IQ. 0 point is arbitrarily chosen, so the value of 0 represents a point in a number line, not the absence of the trait. Ratio, similar to interval, absolute true, 0 point. The value of 0 means absence of the trait, example, weight or the Kelvin scale. Summation, notation. Greek letter sigma, it indicates the sum of all values. N is the number of participants in the group. X is any observed variable that you might measure. Reporting data. Frequency distribution, a method of organizing data that involves noting how often each of the various scores occur. Data. Frequency distribution, a method of organizing data that involves noting how each of the various scores occur. VO2 max for 65 students. Make sure you read your chapter, especially page 40, to get details on this particular chart here. So for percentile, represents the percent of observations at or below a given score. In the previous table, we will see this as a cumulative percentage, a norm referenced comparison. The measures of central tendency is a center of a frequency distribution, a single score that best represents all of the scores, your mean, your median, and your mode. The mean is the average score, the sum of the scores divided by the number of scores. It's the most stable and reliable measure of central tendency and may not be representative of skewed data sets. This is affected by the numerical value of every score in the data set. Median, middle score, 50th percentile, the typical value. A score that divides the distribution of the scores exactly in half. To obtain the median, order the scores from high to low and find the middle one. Works well for skewed data sets. And then your mode is the most frequently observed score, the most unstable measure of central tendency. And this can be more than one mode if 2 or more values are equal. Distribution shapes. Statistical term for a shape of a distribution is skewness, ranges from -1 to +1. The peakness of a curve is referred to as kurtosis. Mesokurtic is a normal curve, plateokurtic is a flat curve, and leptokurtic is a steep curve. And you can see these different distribution shapes right here. Here's 3 symmetrical curves that we talked about. Histogram, a graph consisting of columns used to represent the frequencies of observed scores in the data. Histogram output for 65 scores. Again, there's more information in the book on detailed information, but this is a histogram. Measures of variation, how scores spread out within a distribution. When variation is large, values are widely scattered. When variation is small, values are tightly clustered. The measures of variation include range, variance, and standard deviation. The range, high scores minus the low score. It's the least stable measure of variability because it depends on only 2 scores. Your variance, measure of the spread of set of scores based on the average of the squared deviation of each score from the mean. It's used more frequently than range, and it's the most stable measure of variability. Calculating variance. Calculate the mean, subtract the mean from each score, take the deviation and square it, add the results together, and divide by the number of scores minus 1. Here's another chart of calculating variance. Your variance equals average of the squared deviations from the mean, hence the term mean square. When computing variance from a sample, use the following formula. And here's 3 types of variance: error, true, and total. Standard deviation, square root of the variance. Take the square root of the formula for variance, linear measure of variability. Normal distribution, bell-shaped, symmetrical probability distribution. Standard deviation tells us a great deal about the distribution. And here's a normal distribution of scores. Standard scores, a set of observations that have been standardized around a given M in standard deviation. A transformation of raw scores to common metrics. Scores from different variables can be meaningfully compared using a standard score. Most fundamental standard scores is a z-score. Z-scores have a mean score of 0 and standard deviation of 1. T-score. Another commonly used standard score is a t-score. Mean of the t-score for all observations in a set of data is always 50, and the standard deviation is always 10. Here's standard scores, means, and standard deviations. Their z-scores and t-scores are represented. Summary. Descriptive statistics are foundational to understanding the measurement and evaluation. Understanding and using the concepts of central tendency and variability is important. Using and interpreting the normal curve and areas under sections of the normal distribution is also important.